All right, next up we're going to talk about metadata interrogation. So the idea is that it is possible through Artifact to attach metadata to your components. Of course, this is done using an artifact type, so that's something to watch out for once again. And this metadata can allow you to make additional decisions when resolving the actual type. So instead of injecting the type t, you inject a meta of t. So you would write something like the following. You would register type t, as we've seen countless times already, but then you would specify with metadata. And here you can specify the metadata. It's actually possible to have the metadata both weakly typed, which means that it's just going to be a dictionary of some kind, or it can be as strongly typed where you can explicitly specify an object that you've created specifically for passing in the metadata. There is a bit of a weird lambda syntax for actually assigning the properties and whatnot, but it is possible, it does work. And of course, when you have provided this metadata and you're storing this metadata as a field of type meta of t, what you can do is you can say my field.metadata to read the actual value, and just as we've seen before, you can use myField.value to get to the actual object. We'll see more metadata related examples in the advanced topics, but I will give an example of metadata interrogation here regardless. To illustrate the idea of carrying over metadata, I'm going to get rid of the reporting component innards that we have right here, and I'm going to rebuild it from the ground up. So essentially the idea is that we want to carry over certain amounts of metadata with our console log. So in this case, I will use a meta type, and I will specify the type as console log here. So this is going to be the log that we are actually going to use in the reporting part. So once again, Ctrl+F to initialize the whole thing, and then I'll have a method called report, and here we're going to try doing different kinds of reports depending on the logging level that we want to specify, and the logging level is going to be part of metadata. It's going to be something that is attached to the console log on the side rather than being a field or property of the console log itself. So the idea here is that if you want to use the log, you can still keep using the log using log.value, just as we have with the lazy type, for example. So I can do log.value.write, and I can say starting report, but then I can check whether or not the logging level is set to verbose, and if it is, we're going to do an additional output message. So to check the metadata, I can write the following. I can say if log.metadata, and here I use an indexer to get the mode of the metadata. So you can see I've decided to define the keys as strings, and I say if the metadata is equal to verbose, then everything is okay, and we can do an additional logging. So we can say log.value.write, and in this case I can specify that this is a verbose mode, and we can say logger started on and inject the actual date time, so datetime.now. Okay, so what's happening is I want to check against a certain value in the metadata, but you'll notice that it's a dictionary from string to object. So what this means is that we have to do some casting here. So it's not strongly typed. We have to say as string and compare it with the value verbose. So this is how you check for metadata. Now the question is, how do you actually provide this metadata? So let's go into our main and actually specify the appropriate element. So I'm going to get rid of SMS log because we don't need it anymore. But this time I have a console log. I don't need it to be an ilog for this particular demo. But what I do want is I do want to provide the metadata. So here I can say with metadata, and you can see there are different overloads. The one I'm going to go for is the one where you specify a key and value. So the key here is the mode. That's the key that's being used up above. And the value is the logging level. So in this case, I will choose verbose, and we can now invoke all of this. Now, there are no additional changes that are required, so I will just run what I have right here, and we'll see what the output actually is. Hopefully no exceptions for us. Okay, so we make the console log, we start the report, and then the metadata gets checked. And because we specified the mode as being verbose down here, we have the appropriate output. Now, let's imagine that I change it to something else like info, and I execute the same chunk of code. And what you can see that the line related to verbose mode is no longer appearing in the output. Okay, so the only problem with this entire approach is that it's weakly typed. The key is always a string, and the argument is always an object which needs to be cast to something, which isn't very convenient. Sometimes you want to pass metadata which is strongly typed, and there is certainly a functionality provided by Autofact to let you do exactly that. So in order to demonstrate how this is going to work, what we're going to do is we're going to introduce a new class. So I'm going to have a class here specifically for settings. And let's suppose that one of the settings is the log mode. So I'll have log mode as a public string property here. And then you can have some other properties here if you want to. Now, the thing is, once we've done this, what we can do is we can change the code so that the meta information is specified right here. So instead of just specifying that this is a meta of console log, provided a string to object dictionary, we specify that the metadata is stored in a class called settings. And then of course we have to replicate this and put this in here as well. And now none of the code that we have below is functional because we need to perform the checks in a different way. We now have a capacity of doing this in a strongly typed way. So what I can do is I can perform the same check by saying if log.metadata, but notice metadata is now of type settings. So I can say log.metadata.logMode is equal to verbose. Then I perform the operation. And now, of course, this line is no longer valid. We have to do it differently. But how? Well, the way this is done is actually a bit bizarre. Let me show you. So first of all, we register the type as before of console log. And then we call a different overload of with metadata. So the good news is that here with metadata is generic. So you can specify that it is using the type settings. But then something interesting happens because what you have to do is you have to provide a lambda or indeed a set of lambdas which specify the configuration. So here I'm saying that I want to set certain metadata and then I take the configuration action, and what I do is I say the configuration action is being provided for, so I use the for method here, and then I'm providing it for a property accessor. Notice I will use x, where x is the accessor to the settings type, and here I am providing it for log mode, like so, and the actual value here is going to be called verbose. So this is the second argument of the for method. So the argument is going to be verbose. So let's just put a semicolon here and let me just try and explain what's going on here. So we need to provide strongly typed metadata. And because of strongly typed metadata, instead of just calling with metadata with a bunch of strings and objects, the right hand side is an object, what we do is we do with metadata, which is strongly typed. But now that it's of type settings, what we have to do is we have to take this object here, which is a metadata configuration object. It's actually parameterized by the settings, and we have to call the for function on it. So we're saying that given this particular set of settings, we're going to configure the for. So the for kind of says that for the argument of log mode, we're going to provide the value verbose. And this is how you configure metadata in a strongly typed setting. So now we're once again ready to go. So I'm going to execute this. And as you can see, the output is exactly the same as we had in the previous example, but we have that convenience of strong typing. So instead of taking this as an object and casting it to string and comparing, we can just get the actual properties. And this allows us to use any types. It doesn't have to be a string. It can be an enumeration, for example. And this is certainly a lot more convenient.